Right, this is not the third take of recording this video, I can assure you. Now, Advent Code day 3. Day 1 actually. Well, actually day 403 for me. So, today went wrong at about midnight, where my Advent Code bot, which scraped the leaderboards every 15 minutes, had a little bug where it kept retrying after a failure, and I got rate limited. Because someone added a leaderboard with code 123456. Obviously, that doesn't exist. So it just kept asking every, second, do you have this leaderboard? Do you have this leaderboard? And now I am IP banned. It's only an IP ban. If I use the work laptop and a work VPN, it's fine. But it's just a little bit of an IP ban. So, apart from that, we can't show you. It's something to do with L's and calibration and snow. Really exciting stuff. Basically, you get some input, which I've not got on this machine, because I'm very well prepared. And what it is it's pretty much like a set of, I'll give you an example. So, it's basically a bunch of random letters with some numbers in them. So for part 1, you need to get the first and last number, and have the first number as the tens, the second as the digits of each of these lines, then sum them up. So this first one here, zoom in so you can actually read it probably. You got AS2, blah blah blah, then J3D, so it'd be 2, 3, 23. Then it's the next one, which is a 3 plus a 3, so it'd be 66 plus 23, which is like 80 something. 86 to be honest. That was embarrassing. Good quick maths. So I did this part 1 in Go. So what we got is something which simply it reads all the input to a buffer, a little byte array, a byte slice if we're being technical, and then it iterates over them and pretty much scans the numbers out. So the way it works is I read the file and hope there's not an error, set total to 0, and then if there's a new line, what I do is I reset the current line struct which I've got, which just stores the first number, the last number, and that's it, yeah. And then I add in the tens and the units, then reset it even. So I turn a byte to an in, which is basically chart it in. I don't know why I did it like this. I did it at like 9 in the morning, so I wasn't very awake. So it just scans all the lines. If it's a digit, we set the last digit to itself. If the first number's not been set yet, then we can set the first number. Then that works quite nicely. Now, part 1 is relatively exciting. I've seen people do a lot of dot split. You don't need no dot split. Well, I guess it does work though. But I had a far more interesting time with part 2. So, for part 2, I wrote a LR1 parser, which didn't work for reasons we'll get onto shortly. And what they had in this was the special thing for part 2. You had like the letters, the number spelled as letters such as 1 or 2 or 3, 4, 5, 6 as the actual letter, the word then put on there, and it overlapped, which is something we'll get onto later. So we started by writing Alexa, a scanner thing, so this uses GNU Flex. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got a digit, which is just regex 0 to 9, and other, which is just A to Z. And then we got the .wi-fi, which is a GNU Bison, like sort of Yak kind of thing. It's just a parser here. So this generates an LR1 parser. So we got parse input string. This just sets it up and calls YY scan string, which is the Bison way to scan the string. So the way it works is we start with the input grammar. It's going to be input new line, then a line. Oh, that's not going to get confusing at all, is it? It was a lot less confusing in my head. And then we handle the end of line, or we got an input and a new line. That's if there's a new line at the end of a file, or we've just got a line on its own. That's sort of like a terminal. So we got, let's say you got line, new line, line, new line, line, new line, line, new line, line, and the last one will trigger this all on line 43. Then we got %empty, so that's just end of file. That's when there's not a new line at the end. And then we got we'll go to line, I guess. So new line is a token. It's just \n defined in here. In the parser Doodads. Yeet. And then we got the line. The line grammar is defined as a line letter or a letter. Then a line letter or letter. Line letter isn't a word, so I got confused. I confused my own self with these bloody parsers. That can't be good. So that's just like box standard non-terminal with a bit of the old ed recursion. Very exciting. So a letter, it's either a valid digit or other. Valid digit, it's going to be an actual digit, 0 to 9, so we're just going to go YY text, that's the current buffer. For the token, it's parsed. We could get the 0 index. We could check the length, but to be honest, I know it will always have at least, well, precisely one character in it, and also I simply don't care enough to check the length. Then we minus the character 0, that's just because you got ASCII tables, so you get the characters and you minus 0, that's 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9 just comes straight afterwards in the ASCII table. It's a nice little trick there, and then we just handle that. Then we've got similar things for 1, 2, 3, 4, 5, 6, 7, 8, 9, where it just handles it with the correct number. And we've got this function handle number with line. Where does line come from? Very good question if you've asked that. So, we've got this parse param. This is the parameter that every action in the grammar gets given. So we've got a line which is a pointer to the current line, which we get to in a second. And before that, we have a look at handle number. It's the same logic from part 1 basically, but just in C with this debug statement because of a weird, interesting edge case to do with overlapping tokens, which we'll get to later, as I said. Then handle end of input, it just, that's when you've got to the end of a line basically. That just takes the first thing, times it by 10, then adds the last, then it resets first and last to the default state so that we don't reuse old input. So then, this current line, where does that come from? I've not even opened the file, how exciting. It comes from parse.h. Why did I call it parse.h? I've got no clue. So, we defined a function to parse, it just returned an int, which is actually its status code, not the total. That's not going to get confusing, is it? Then we've got the struct of current line t, it's just got first, last and total as integers. Nothing exciting there. Then in part 2.c, what we do is we just get a file, open it, try parse, print an error if something's gone horribly wrong. And then in this, what we do, it's actually quite interesting because I copy-pasted this code because I could not be bothered. So try parse, it's a restrict f. What does that mean? Absolutely nothing. I'm going to get like one extra cycle of performance. It's pretty much meaningless. But basically the restrict keyword in C means that this pointer will not be modified by anything else than with the f handle. So it won't be aliased or assigned to anything else basically. It's very boring. It's actually a bit more complicated than that. That's basically the gist of it. To be honest, it's a shit keyword and I don't know why I used it. So we do fseek to the end. We go to the end of a file. I'd imagine on a hard drive you see the disk spin it. No, of course, no you wouldn't. So we open the end of a file and then we do ftell. That just tells us the current position we're at, which is the size of the file. Then we do rewind f, which just sends it right back to the start of the file so we can actually read it. Now we know how long our file is, we just pre-allocate a massive array. Oh, is it? Oh, bugger. It's not null terminated. This is a disaster. I've written a bug. Let's fix the bug in a second. Carry on explaining. Then we read the entire file to the array, and then we parse the input string with the array, then free it. The string, not an array. But I forgot to null terminate it, which means we've got some legendary undefined behavior. This code could die, and no one would know why. Let's fix it now. +1. There we go. Then I'm going to set f content of f size to 0. Checkmate undefined behavior. So that should now work. We shouldn't get random errors to do with null terminated strings. Yeah, that's a fun bug, isn't it? So yeah, the parser had an issue related to overlapping tokens, as I mentioned, but what the frick does that mean? Basically, let's take this as an example line, where we've got 1, 2, 3, 1, then 8, but 1 and 8, they're the same, like the E from the end of 1 is the first letter of 8, so the parser sees that as 1, then ite, that's not 8, we can't parse it, and it just thinks that's other letters. However, The problem wants us to have it so that's 1 8, as in with the same shared E, is 1 and 8. So instead of this being 11 as the output, it should be 18, because the 8 at the end, which I pressed the wrong button. This 8 should not be treated as part of the 1. It should be treated as a 1 and as part of an 8. But my parser doesn't do that. It looks at it, it sees 1, it accepts it. We handle the input for 1. Then we see I. We got nothing with an I. That's other noise. Same with a G, H, and T. And that means we get 11, which is wrong. So, there's ways to fix it. I could write another parser. To be honest, I am all out of theory, and my textbook hasn't arrived yet. So when you hear my door ring with a textbook, I get very excited. So what I did was I made a bash script, dirty.sh. So what we do is we run a sed command to find a place from the numbers 1 to 9. So what we do is we take 1 and replace it with the letter 1 followed by its last number, which means if we take the number 1, 8, where you've got it like that, it will change it to 1, 8. We can parse that now. Excellent stuff. Well, actually, this will then be followed by the ones for all the other numbers, so they'll actually get turned into 1, 8. Which means my parsing is even easier. However, this is not how you should do it. If you do this in production, you are a plonker. I only did it because it's quick, easy, and I simply couldn't care less. To be honest, I should write a different parser which does accept the input. However, I don't know how yet, and my bloody textbook's not here, so we can't learn how yet. So that's day 1 of Advent of Code. Very exciting. Filled with exciting things such as parsers, 403 errors. Sorry, Mr. Advent of Code, for spamming you. To be fair, it was only like 5 requests a second from about midnight to 2 o'clock. I wouldn't think about it too much. Was only like 14 hours of 60 times 60 times. It was only like 250,000 requests I sent to the Advent of Code server. I really wouldn't worry about it. Hopefully they stop IP banning me, because I fixed a bug and it would never happen again. I promise, Mr. Advent of Code, please unban me. So tomorrow is day 2. It's a Saturday, which is even more exciting. There is a non-zero chance of doing Advent of Code with a minor hangover. That could be exciting. No, it won't. It won't be exciting. Well, I hope you enjoyed today's explanation of Advent of Code and all the exciting errors I had. Like and subscribe, I guess. You can even leave a comment if you feel so excited, you know. Have fun. Right, I hope you enjoyed Advent of Code as much as me, and I'm going to stop rambling now. Goodbye.